So in class, we've already kind of started talking about what you already know about functions and relations and the difference between the two. And another big question we're going to look at is how do we know when a relation is a function? So all of these things are objectives that you should get out of this video. So a relation is any set of points on the Cartesian plane. The Cartesian plane is the graph system that you're used to working with. So x and y, this is the Cartesian plane. So a relation is any set of points on this graph, on this plane. And so an example, or several examples of those, this graph here, this linear equation that's graphed here, is an example of a relation because there are many, many points. There's an infinite number of points on this line. This is also a relation here. There's an infinite number of points on this function. This is also a relation here. It says all the points in the first quadrant are a relation. So every single point in this quadrant, every one of them, we can call a relation. Okay, and then this is also a relation. These 13 points form a relation. Okay, so a function is a type of relation in which no two different ordered pairs have the same x-coordinate. Meaning for every x-coordinate, there's just one y-coordinate. So we can't repeat any of our x-coordinates and have different y's. And these are two examples of functions here. And we'll look at the two different tests. There's the algebraic test, which the substitution of any value in for x gives us one and only one value for y. And then there's also the vertical line test or the geometrical test. And this we need a graph, or we need to be able to produce a graph in order to test it. So if we draw all the possible vertical lines on a graph of a relation, the relation is a function if each of the lines cuts the graph no more than once, and it's not a function if at least one of the vertical lines cuts the graph more than once. And we'll look at that. Okay, so using the vertical line test, this is the geometric verification of whether or not a relation is a function. So looking at these relations, we have to determine, is it a function? So if we do the vertical line test with A here, we draw multiple vertical lines, we can see that they never pass through the function more than once. It's always just for every x, there's exactly one y value. So this relation is a function. Letter B, if we do the same thing, so we do a vertical line test. And again, same idea. Every single vertical line only passes through our function once. It hits, each vertical line just hits the function at one point. So again, this relation passes the vertical line test, which means it is a function. And letter C, right away, we can see that this relation does not pass the vertical line test because this vertical line happens to hit the function twice. So does this one. But we just need one vertical line to hit more than once in order for it to not be a function. So letter C is not a function. So it's a relation, but it's not a function. And that means that for every x value, there's not necessarily just one y value. You can see here when x is at this value, y has two different values. Okay, so more vertical line tests, and hopefully you can try these examples as well. Oh, and also, if we're given ordered pairs, we should be able to determine whether or not a relation is a function. So looking at letter A, in number 1, we can see that every single x value is not repeated. They're all different x values. So that means for every x value, there's just one y value. So yes, this one is a function. Letter C, we can see right away that x is repeated, not only once, but multiple times. And so notice for every x value that's 2, we have different y values. We have y could be 1, 0, 3, or 11. So letter C is not a function. Okay, letter E, we have x values of 0, 1, 3, 5. They're all different. So this is a function. Because for every x, there's just one y. And that y does happen to be 0 in all those cases, but as long as the x values are different, that's okay. Okay, and then again, what is this, letter B? We've got the x value of 1 repeated, so this is not a function. Letter D here, we've got x values of 7, 5, 3, 4, no repetition of the x values, therefore it is a function. And then letter F, again, repetition of our x values means that it's not a function. Because for when x is 0, we have many different y's. We have y could be 0, 2, or 4. Okay, more vertical line tests. So I'll let you try those ones in the answers here. Yeah. And I'll show those as well. So vertical line test, as you can see in A, this relation is a function because it passes the vertical line test. Every vertical line hits the function only once. Same with letter B. It is a function because every vertical line only hits the function at one point. Same with C. So even though here and here, the function gets really close to vertical, we know that it's actually not vertical because it's an asymptote. And we'll talk more about that in the future, but it does pass the vertical line test because it's not completely vertical at either of these places in the function. So this is a function, letter C. And then letter D is not a function because our vertical line hits the relation at more than one point. This one too. So not a function. Okay. E again is a function. You can see it passes the vertical line test. F is not a function. Hits the vertical line at more than one point. G does pass the vertical line test, so it is a function. And H passes the vertical line test everywhere except here. There's 2 points that it hits, so this is not a function. But it does pass the vertical line test here because this is an open point, meaning it's not an actual point. It's a hole on the graph. So this vertical line only hits the relation at one point, And same with this one. It only hits the relation at one point because this is a hole. It's not really a point on the relation. But still, because it doesn't pass the vertical line test at one of the vertical lines, it's not a function. Okay, these are some good questions down here. Will the graph of a straight line always be a function? Will the graph of a straight line always be a function? So thinking about that, we can see in letter A we have a linear equation. If you think about certain type of straight line, we have a vertical line. This will not pass the vertical line test, because if we were to draw a vertical line over that for the vertical line test, it would hit over it would hit an infinite number of points, which means it does not pass the vertical line test. So vertical lines are not functions. But every other kind of linear equation is. So a line with a positive slope, a line with a negative slope, so positive slope, negative slope, and even a horizontal line, these are all functions. But the vertical line is not a function, because it doesn't pass the vertical line test. Okay, and then x squared plus y squared equals 9, we want to give algebraic evidence to show that it's not a function. So x squared plus y squared equals 9. So we could, when we're giving algebraic evidence, we want to show that if I use one x value and get a value of y, I can use another x value and get the same value of y. Or no, actually, right, so we'll use the same x value to get two different values of y. That's it. So for example, let's see, x squared plus y squared equals 9. So we could use x equals 0, for example. And when x equals 0, we could say 0 squared plus 3 squared equals 9, which means that y equals 3 when x equals 0. Still using x equals 0, we could also say 0 squared plus negative 3 squared equals 9, which is also true, which means that y equals negative 3. So we've just created the point 0, 3, and we've created the point 0, negative 3. And that shows that this is not a function, because we've got the same x value and two different y values. Okay, this symbol right here is read f of x. F of x is the value of y for any given value of x. So we can say that y is equal to f of x. You might also see it written in this form. It means the same thing, f max onto x. But you could also say f of x is equal to 2x squared minus 3x, and we want to find the values of f of 5 and f of negative 4. So to find f of 5, we're just simply substituting 5 in for x. So for every x, we'll substitute a 5. Okay, so we've got 2 times 25 minus 15, or 50 minus 15. That gives us 35. So f of 5 is equal to 35, and then f of negative 4 And it's important to keep our negative form brackets as we're substituting it, especially when we're dealing with powers, like we are here. Okay, so we have 2 times negative 4 squared. So using order of operations, we square our negative 4 first. And we have 2 times 16, because a negative number squared, or a negative times a negative gives us a positive. And then we have negative 3 times 4, which gives us positive 12. So we have 32 plus 12 gives us 44. So f of 3 is 44, or sorry, f of negative 4 is 44, and f of 5 is 35. Okay, and we can do that without necessarily substituting numbers. We can also substitute variables for x. And these are 2 examples of that. So if we wanted to find f of negative x, given the function above, we're just simply going to substitute negative x in for each of our x's. So we've got 5 plus x minus, and then if we square a negative x, if you think about it, we've got a negative x and it's squared. So we've got negative x times negative x, which gives us a positive x squared. So we've got minus x squared still. This minus came from here, and the negative x in brackets squared gave us a positive x squared. And that's it. So this is our function, f of negative x equals 5 plus x minus x squared. Okay, and then we can also find f of x plus 2. And we're substituting x plus 2 in for each of our x's. So 5 minus x plus 2 minus the quantity x plus 2 squared. And it's important to simplify it too. So remember to distribute your negative to both terms. So minus x minus 2. And then we have to FOIL x plus 2 in order to square it. And we should keep our negative outside for now. So we have x squared plus 4x plus 4. And, okay, so we have 5 minus x minus 2, which gives us 3 minus x minus. And now we can distribute our minus to each of these terms. So minus x squared minus 4x minus 4. And we get negative x squared. And we have negative 5x and a negative 1. So this is f of x plus 2. Okay, and that should be it. So, so the difference between relations and functions is that functions only have one x value for every y value, and they do pass the vertical line test. Relations are just any combination of points that we can find on the Cartesian plane. We also looked at function notation and substituting into a function. Okay, thank you.